Okay, so just a quick bit of revision. So we saw these slides on Wednesday last week. So development plans, go to the Planning SA portal for all of our information about changes and so on with the planning system. We've got so much upheaval happening at the moment. It's not our current system. We teach the current system, but look, as we get through this subject and as we get through this semester, things will unfold as to how this is all going to be playing out and implemented. We can have a bit more of a chat about this later in the semester. The structure of the development plan, so every single council, so we've got different councils around the place, they have their own development plans. Of course, we have an index. An index is very important, tells us what everything is in that development plan. We've got general provisions, so council-wide policies which apply across the entire council area. So they set that general framework, and then beyond that, they'll have their zone provisions. So we've got things like primary industry zoning, industrial zoning, residential zoning, institutional zonings, etc., commercial zonings. Got all these different zones because we create our built environment differently between those different areas. Then we have our policy area provisions. So we could be, Adelaide City Council, City Centre Zone Policy Area 13. So we can have those various different layers. If I have something that deals with if the council-wide objectives say setbacks from secondary arterial roads are 14 metres, and then I have another in my policy area says setbacks for this policy area must be X many metres. What bit takes precedence?
Policy area.
Policy area in the main. Yep, and that's it. So as we get more and more detailed about our property, like when we get into our policy areas, that's what takes precedence over the other information that came beforehand. Sometimes there will be other inputs that mean that, okay, we've got this happening in our policy area, that's what it says for our policy area, but we've got traffic conditions that have to be adhered to. Well, then we have to abide by those. But in the main, that's spot on. Our policy area takes precedence. And also then we also have sometimes precinct provisions. So areas that tend to be smaller than policy areas with specific attributes, usually a sub-area within a zone or policy area. Not very common, but sometimes you'll have those if there are intended works. So if there's a road which is meant to be happening through this particular bit, it's only through part of a policy area, I'll say these are the rules around that policy area, but there's this little bit here that includes 4 or 5 allotments where we plan to build a road. We're not going to let you do some things in that for thinking about the future. And then after that, we've got all of these sections will reference various different tables. Because as you know, some information is presented well in a long format, and then other information dealing with dimensions and numbers, etc., is quite often better displayed in a table format. So they'll have provisions around car parking, and I say, if you are this particular class of property, then you have to have this number of car parks for this square meterage of your building. So there'll be all these tables that give that information as well. And then beyond that, toward the end of your development plan, you have a whole series of maps that tie that information back to a geographical context. So yes, SA Map Viewer has kind of done away with the necessity to refer to those in large part, because a lot of that information is included on there. But still check them out, because not every bit of information will be included on SA Map Viewer. One of the, actually, I think significant trees aren't shown on SA Map Viewer, are they? Has anybody found significant trees on SA Map Viewer? I think they're not. Like, yes, you've got heritage, places of heritage included on SA Map Viewer, and that's relatively detailed, but significant trees aren't. That's something we have to deal with in this subject, is significant trees. You're still going to have a look at those maps. So you're still going to have to look at the map index, work out, okay, this is where we are within this. Do we have a significant tree on our property? Because that will change things. So they're not entirely superfluous. So we've got general provisions. For this is just where did I grab that one from? I grabbed that from the planning portal, but it shows your various different council areas centred around Adelaide City Council there. And then zone provisions. So that's a map showing the various different zones. And you can, this is our city centre. You can look at that and think, oh, I know what's in these areas. Like, that's why we have different zones. So this light blue bit, okay, that's commercial, predominantly commercial. We've got some residential and so on. City centre, we've got some mixed. It's primarily commercial. Whereas these pink bits, they're primarily residential in the Adelaide city centre. And then, we've got primarily residential in North Adelaide, except for these little strips there. Does anybody know which either of those little strips are?
That North East Road.
Yep, O'Connell Street up there, straight up there, and Melbourne Street. So we've got those two sort of business centres through North Adelaide, different zonings. This end of Melbourne Street is treated differently than this end of Melbourne Street, because this end of Melbourne Street primarily has office accommodation. And then right at this end, it's like right by the Women's and Children's Hospital. Yeah. So that's what we can see. And and we've got various, so from looking at this, if you have an idea about what's around Adelaide, you can go picking, oh yeah, I know, the parade in Norwood. I can see the parade in Norwood in the zoning constraints, etc. And then policy area provisions. So I spoke about that policy areas before. What we're doing in this little section here is going to be different to what we can do in this little section there. So we're looking at Adelaide City Centre. Now that's all blue. Now this here, whoops, that there is a snip of this bit here. So it's all blue. It's all commercial centre zone. But then we get into that and we go, all right, Rundle Street, that has a different policy area than North Terrace. People are doing different things on Rundle Street than they are on North Terrace in a built sense. We're talking about more cafes, retail, public interaction. North Terrace, it's much more grand buildings, institutions, office accommodation. Different drivers. And then, I spoke about those precinct provisions. So I think is that Lobethal, I think? Up in the sort of just back in behind the range. Yeah, one of those Lobethal Woodside, one of those. So intending to do a road through there. So these properties, there's a specific precinct provision in that to say, look, yes, you're within this policy area, but this bit here, we're not going to let you build right to the front or certain distance, because something's going to happen here later on. And then our tables. So, as I mentioned before, vehicle parking, off-street vehicle parking, and maps. So this is a map index showing how that's broken up into various different areas. So that one's Adelaide Hills Council Airport building heights map. So that's another thing. We might not be building next to the airport, but anybody who's lived in North Adelaide or spent any time in North Adelaide, you realise that there's plenty of impact from the airport in North Adelaide, as the planes coming in, they hook down really low. You don't want to be building a really tall building in North Adelaide for that reason. Well, the council doesn't want to do it. That's why they've worked all this out. So yeah, so we've got maps, transport, heritage, development constraints, natural resources, bushfire protection areas, policy area maps, etc. So we've got the whole series of maps. Actually, and that's another. I haven't looked on SA Map Viewer to see if that includes building heights for airport consideration. I don't. Maybe there is. Never looked at it before. But some of these things are still only in the development plans. Not everything is on SA Map Viewer. So that's a bit of a recap of what we're looking for in terms of dissecting the development plan from council and what we should be thinking about. And then finally today, so we've got 1 hour left. Talking about external consultants, so that's, if you look on your timeline, that's actually what's in this block of time for this week. You'll have a quiz. So to access some information, you have to fill out this quiz. You get a few shots at it, you should be fine. Right? Put that simply. So there's a whole host of other people we may need to employ in a building project to get something done. One of the ones pretty much guaranteed that we will have to is a geotechnical engineer. Now that might be the same person who's a structural engineer to design the slabs. Quite often it will be, because they're dealing with the same thing. They're wanting to see what those characteristics of soil are, so we know about the foundation, so we know how our slab design has to be. Or footing design in general. So it's not only slabs we use as footing, sometimes we can have isolated piers. We still have to know what dirt we're on for that. So yeah, so we got to see that this morning, somebody taking soil samples. So this morning what they were doing is they were drilling down to get to that water, to take some samples of the water to to look for contaminants. I don't know if anybody remembers the news around this years ago. Look, I don't want to make assumptions about what they're looking for, but there was tetraethyl chloride in the water from polishing aluminium, because if it gets polluted over there, because of the way our aquifers work, get polluted in various different areas. So in quite a few instances, particularly where you have had industrial activities being carried out before, you will get these this hydrological sampling that has to take place. We'll talk a little bit more about that later on. Typically, it's not going to be an issue. It's not going to be something you're commonly searching for. That is one of the rare examples. But what you will be looking at is getting soil sampling done. So we have, whenever we're doing a development, if we don't have any soil samples for the site, we have to take a minimum of 3 core samples I can't remember what the base minimum height. I think the depth is base minimum 3 meters, but the company I used to work for would specify going down to 4 meters. I know that was in excess of just the base requirements, but what we deal with in South Australia is we have reactive soils that go down quite a long way. We've got clays which they take moisture, and those clays, when they take in moisture, they swell up, and some of that swelling can happen down as deep as that 4 meters. So although we've got this cut off at 3 or 3.5 meters, I can't remember what it is, typically your geotechnical engineer is going to make that assessment of, we've got to go down to this particular depth because we've got deep-seated clays in South Australia. The other reason they might want to go down quite deep is because not only do they want to see how far those clays extend to work out reactivity, But if we've got reactive clays happening over top of a solid base, sometimes for some building options, it's worth going all the way through that reactive clay with our footings, locking into that solid base and elevating our floor up above the ground. So then the soil can do whatever it wants. It's going up and down, and our isolated pier footings are sitting locked into that, into what's underneath. So sometimes the geotechnical engineer is going to want to know what's down underneath there. And we saw that this morning, that we didn't see the push tube being pulled out, but we just saw the results of that, which is all of our soil laid out in those core flute trays. So the engineer can look over that and go, all right, well that's bitumen, that's compacted rubble, right? We're getting into natural soil here. We've got a firm clay loam with a with a good bearing capacity. So that soil sampling will be taken, and that soil will be kept for as long as it's required to be referred to. Then the engineer looking at those soil samples is going to produce bore logs. Those bore logs is basically a table of information to say this is, so you start with, and I'll draw this, very simple table. Sorry about that for those at home, but please imagine I'm drawing a very simple table with some columns. The left-hand column is going to have our horizons in it, A, B, C. This is super simple. Right, we've got our horizon A, that's the soil that's at the top. Our soil at the top will contain humus, organic matter, things like that. It's going to be 400 mil deep. Typically 400, let's say, and then that will, will go from 0 to 400. So that top bit starts at natural ground level, and it's about 400 deep or so. Then beneath that we'll have, let's say we've got clay with small sandy portions, sandy pockets. Then after that we'll have clay with weathered rock fragments or something like that, and then under that maybe we'll have sand, weathered rock fragments, and small pockets of clay, or something like that. So as we get deeper and deeper and deeper, we get that information about what's in the soil. And then across the top here of our table, we'll have borehole number 1, borehole number 2, borehole number 3. Those horizons may be different for each borehole. Like let's have a hill here like this. We've got our first horizon, our second horizon is doing that, our third horizon is doing this. We do a borehole through this, we're going to get a bit of A, lots of B, and a bit of C. Do one here like this, not so much A, plenty of B, not very much C. And do one here like that, we'll get none of A. Get a little bit of B, stacks of C. So you've got, when you look, if ever you go down to the beach and some of the southern beaches or so, you look at those cliffs there, you see these horizons of soil like that, and you'll see that sometimes they're really thin, and then other times that same horizon of soil is quite fat. That's what happens underground. The geotechnical engineers are going to want to know that, because that tells us what footings we can do. And also, it's not just about going, okay, this is the reactivity of the soil, this is how thick our footings are. Sometimes we're building on a place that has none of that horizon A and very little of the horizon B, but then that's going across this bit like this, we're cutting into the soil. We might have far more reactivity at one corner than we do at the other corner. That's actually a bigger problem than if we had uniform reactivity across the whole slab. Because slab cracking, building cracking, it's about differential movement. It's not only about total movement. So we're going to have soil samples, well pretty much always we're going to have soil samples done. The only time we're not going to have soil samples done is when those soil samples have been done by somebody else. We need to know what we're building on. The council want us to show that we know what we're building on. And the builder's going to want to know that we know what we're building on. The builder doesn't want to go doing their slab to AS 2870 and find out that that slab's been designed wrong and they have to pick up the bill because they didn't pick it up. So plenty of people won't want to allow anything to move ahead unless that has happened. And yeah, we get our foundation characteristics from that. Predominantly in South Australia, particularly in the metro area, you're going to be dealing with clay soils and the reactivity and the problems with clay soils and differential movement. In some pockets around South Australia, you do have collapsing soils as well. They're really not very common here. That's where you add moisture, it lubricates sand particles, they fit together better, your foundation shrinks. Typically it's upheaval that we have happening here. But we've got to get that done. And as I mentioned also earlier today when we were out there, that's typically going to be on the back of a Land Cruiser size, like full drive. They're not, you can get them into most places, and they'll get the soil samples done. But you're not constrained to that. Sometimes, as I said before, you can do a soil sample inside a building. It's just much more annoying to do so. You've got to carry the A-frame in there, take up floorboards, push your push tube in there with a two-stroke hammer, and then pull it all out and get your soil samples done that way. But all these things can, they can happen. It's just a little bit harder in some situations. And also for hilly sites where you've got limited access, initially, yeah, look, it might have to be all manually done. But can be done. And why, can anybody tell me, this is a bit of a, no, it's not that tricky question. Think about soil samples, horizons, all that sort of stuff. Why would a soil sampler stop at 2 metres?
If they hit rock.
Yeah, bang on. Yeah. Once you hit rock, well, you've hit rock. That's it. That's all you can do. Yeah. And the other reason for that is, if you don't have main sewer there, you're on a septic system. You do your minimum 3 soil samples where you're building your house, and then also think about where am I doing my septic system. You're going to do about 2 metres deep there, 1.5 to 2 metres deep there, to see how that effluent is going to soak into the soil. So for your on-site wastewater, we've got to, the way we deal with on-site wastewater is letting it soak into the soil, because that way the microbes and everything can deal with it. It'll, feeds trees, etc. That's the way we deal with it, but we want to see how that can happen. If we've got really clayey soils, we're probably going to be dealing with something like about 200 square metres of a dispersal area. That's a massive amount of area to fit in to a design. If we've got sandy soils, we might cut that back down to around 150 square metres. But be aware of that as a constraint. And also on hilly sites, that is a massive constraint, because you can't do your soakage within, or but can't remember the figures, but a certain slope, once it exceeds that certain slope, you can't do your dispersal and various just on with sprinklers on the ground. So you've got to dig trenches, build retaining walls, all this sort of stuff. But retaining 200 square metres of land is a big cost. Important to be aware of those things and think laterally about all that stuff as well. Because actually that's an external consultant I didn't include on this. We're not dealing with that in any of our projects in planning approval, but that if you're doing a development where it doesn't have main sewer, one of the other external consultants you're going to have is a wastewater engineer. You have to go through a wastewater engineer. And if you go to a major building, if your client's going to a major building company, they will just go, right, that's our wastewater engineer, and they'll come back with answers and say, you have to do this. My experience has been that I've actually forged a relationship with a wastewater engineer, contact them, go, this is what we're looking to do. This is what I think, get a bit of an appreciation of how this can all be designed to meet the requirements, take it to the wastewater engineer and go, this is what we're really wanting to do. Can we do that? Is there any tweaking that needs to happen? So it's good stuff to know, because otherwise it's expensive and can be a real restriction on what you do. So we've got the geotechnical engineer, we've got the surveyor out. So probably everybody, I was pulling these things together this morning, some slides and some pictures, and Google search surveyor. So many of your pictures of surveyors are guys looking through theodolites to to this thing in the distance. Yeah, of course, people still use theodolites and numpy levels, etc., optical, but technology in this regard has become really advanced, much cheaper and far more accessible in that surveyors, so we had a surveyor out of going through this process just a couple of weeks ago, where what they use is a machine called a Trimble. That Trimble talks to satellites about the place until it goes, yes, I can be really accurate with this point that we're at, and it can take 5 to 10 minutes to do that. So you're sitting there for a while, chatting about stuff, but the Trimble will locate this point, and it will locate that point height-wise and distance-wise in geospatial fashion, and then there's still a lot of investigation that has to happen to find old survey marks, steel pins buried, almost 100 years ago, that sort of thing. You're doing all that, but typically it's not happening in optical fashion anymore with lots of maths. All that maths is done by the machine. Well, a lot of that maths is done by the machine. The surveyors still have to do a lot of working out back in the office, but they're using this connection to satellites for finding points about the place. That technology is becoming cheaper and more accessible. One of my students last semester did some work experience with Smith Brothers Plumbing, and he said what they do is they have a Trimble there as well. So they log all that information about where their plumbing runs go, so that, like for larger commercial projects, so when they go back, they can take the Trimble back there and go, okay, oh that's where our thing is buried in this slab. Because it provides that insight, and so this type of equipment is going to become, I imagine, just used by all sorts of different building professionals, and it's going to be far more readily available. So what you can't do is just go out and buy a Trimble and go, all right, I'll be a surveyor and I'll just tell people where their boundaries are. Look, I'm not suggesting that you should work with boundary surveys or anything like that, but you can, use it for locating features to a very accurate extent using GPS technology. So that's what's happening. So yes, one of the important things that surveyors do is they define boundaries, because it is super common that buildings intended to be built on boundaries are not actually built on the correct boundary. Encroachments happen all the time. That, for various different reasons, sometimes it's negligence, sometimes people intentionally encroach and hope they'll be fined, that sort of thing, whatever. There are encroachments that happen all the time, and those boundaries that are shown in the information in the Lands Titles Office are those accurate boundaries, and it's up to the surveyor to interpret that information into pegs on the ground and say that this is your bit, that's their bit. So very important thing that the surveyor does, but that's not all that they do. Sometimes they're setting things out not in a legal sense, but just simply in a building sense to get some very accurate placements on the ground. Now, typically your people doing site works and footings will also be doing that, but you can have surveyors come out and do that in a very accurate sense as well, finding locations and things. But one of the super cool things one of the really cool things that the Trimble does, talks to other programs to produce contours. Has anybody ever produced contours through the old sort of mathematical manner of getting spot heights and interpolating from that? Anybody done that? You've done that? Yeah. It's a lot of work, yeah? Yeah. Bucket loads of work, takes you many hours, whereas there's now that technology, and you can what are they called? Micron instruments. Go and hire one of these things, go out, take points about the place. Once it's talking to the satellite, taking your points is really easy. Get that point cloud. I don't know what program you use, but that point cloud can then talk to a program to produce really accurate, detailed contours. So that's one job that's become so much simpler, a contour plans. But like I said before, you're going to get this information from various different sources. You've got to get that to talk to Revit or so. Not all surveyors producing things in Revit models. They've got all sorts of different programs. So they'll take a point cloud to create that contour plan. And then if you want certainty around your survey, you can then lodge that survey with the Lands Titles Office. There are certain sort of hurdles of checks and balances that survey has to go through. The Lands Titles Office won't let anything in that is not up to scratch. So they'll want to ensure that, yes, that all of that background work has been done accurately, and then it goes to the Land Titles Office. So if you're getting a boundary survey, it's going to cost you, X if it's just for the pegs, but if you want it lodged with the Land Titles Office, it's going to cost you X plus, probably X plus extra. It's quite a bit more expensive. Oh, oh yeah, it is the right one, yeah. So, the other thing I didn't mention, so you're not always going to get a surveyor out. Sometimes you're going to have the contours to the accuracy that you need them to be. Right? On a flat site, you're not dealing with much. You could go around with a laser level and go, okay, we've got this amount of fall here, we've got to account for that. Over our footings, that's fine. Many instances, you won't actually require a contour plan. Also, if you're not building on the boundary and there's no interaction happening with that boundary, no constraints provided from that boundary, you might not need a surveyor to do that boundary identification either. So you're not always going to need to have a surveyor. Same with an arborist. You're not always going to need to have an arborist. If you're building, out on a paddock with no trees, there's no need for an arborist. Or even if you're building in a place that has a few small trees, etc., probably no need for an arborist. But where you will have to have an arborist is where you've got large trees that you either want to take out or they pose significant risk. So the arborist can make a determination on tree health. So they can look at vital signs around those trees and they say, okay, this tree is suffering from this thing, or it's this, this particular age, it's going to do this thing in the near future. So one of these things can be sort of formation of cracks in the main trunk. If that tree's going to come over, we want to know about that before it actually comes over and falls on buildings and things like that. So the arborist will make that determination. Other things about tree health, they're going to look for fungal activity. They're going to go, okay, well, we've got an infestation of this particular type of fungus, which means that tree has started dying from the inside. It started to rot. The fungus is eating those sugars which are coming out from the decaying material. So the arborist can see, okay, there's this thing happening. They can have a look at the tree and go, okay, we've got borers happening and it's creating this dieback and whatever. So they're going to look at all those vital signs around tree health and they're going to tell you, is that tree going to be a danger to anybody? Is it going to be falling over, dropping limbs, that sort of thing? And so after they've done that determination on tree health, they can provide recommendations on pruning or removal. If you've got a significant tree or a regulated tree on your property, you can't just go in there and chop down. You have to put that application in through council to do so, because it's very important for the built environment in the metropolitan area to have lots of greenery. It's a very important thing, and it's not something that we can just put up overnight. We can't build trees. Because of that, councils are very restrictive about the removal of any significant trees. If you've got this place, your client saying, I want to build this thing here, which necessitates the removal of that tree, if that tree should actually be removed for other reasons, well, then you get that report from the arborist to supply to the council to say, this tree must be removed for these reasons. Not just because we want to build a house here, it's because of all these other reasons. You've got to go through that process with council to get their approval to do so, and getting the arborist report is an essential part of that if you're taking out significant trees. or pruning them to an extent. And can't remember the Australian standard off the top of my head, only referred to it a couple of times, but there is an Australian standard for protection of trees during construction as well. Definitely your wastewater engineer is going to know about that one, but you also your arborist will know about that as well. There are a couple things in that. There's structural root zone, so trees need a certain amount of roots to be able to stand up. If you chop off half those roots, it'll fall over. So there's the actual structural root zone that you can impose upon a little bit, but not enough to cause damage. And then around that tree, there's also the tree protection zone as well. If we build Burnside Village around that tree, impose on that tree protection zone, it might not survive that. So there's an Australian standard for tree protection zone and the structural root zone. But then something that a lot of arborists do then is carry out tree removals. So this fellow is going up, well, possibly what he's doing, I don't know, but possibly going up there, chopping off limbs and lowering them down. Other external consultants, CFS referral. So Country Fire Service, sort of in two parts. You've got the local brigade, the volunteers and everything like that, and then you've got CFS as an organisation. Whenever we're building in bushfire-prone areas, and it's deemed to be high bushfire risk, that's bushfire attack level 40 or flame zone. Whenever we're in 40 or flame zone, it requires a CFS referral. So we can't go getting planning approval for any of that development until it's had a CFS referral. So it's enshrined within the Minister's specification, Minister's regulations, sorry. We've got specification and regulations. In that Minister's regulations, it's enshrined that CFS have to have a say about a development in the high bushfire risk before you go building in there. The reason for that is that insurance companies don't want to be insuring properties that can't be protected in the case of a fire. So if you don't have that referral, well, you won't get planning approval, but then you won't be able to insure your place. But also, the main thing that all the brigades and the volunteers will be doing in the event of a fire is they'll be going out and they'll be trying to protect people's houses. I mean, that's what they do, typically working in their local areas to do so. They probably know the people who own that house that's under threat from fire. That's going to be their natural inclination. But councils want to ensure that those CFS volunteers and brigades are not put in danger because somebody has chosen to build a house in a crazy location surrounded by amazing vegetation that's going to pose a real risk to anybody trying to save that place. So they have to have that referral. So the important things for them are they provide determination of access. They'll look at that access. They'll look at the plan you've put together to say, yes, that access meets our requirements for being able to manoeuvre our vehicles. They're really concerned about, can we drive into the property forwards, turn around and drive out forwards. They want to make sure that they're not going to have to drive down a thing, find nowhere to turn around and then reverse the truck up for a couple hundred metres in a hilly area. They want to be sure of that. They also want to be sure that when they drive in there, that road is going to be in good condition, that they're not going to be driving in and then find a patch where it's just really boggy, whatever, and they have to reverse out another couple hundred metres again. So they'll have a look at your access, have a look at the slope relationships, the turnaround areas, and the covering of that road. And so say, yes, you can build here, no, you can't on that. So that's a very important thing for you to understand. That's, once again, all enshrined in the Minister's regulations for that. They'll provide a determination on bushfire attack level. So bushfire attack levels, they can be calculated by reference to AS 3959. Two different ways. Method one, really simple way, you just look at the vegetation. They've got some various different tables and diagrams saying this is heath, this is open forest, blah, blah, blah. You look at those things, you go, okay, this is our slope of our land, compare those things, look at the table, determine your bushfire attack level. That's a very simple way, but that has restraints on the slope of your land. If you're really steep like this, then you have to do method 2, which is a lot more maths involved. A lot of algebra in working out what that bushfire attack level is. I encourage you to get into that and learn all that stuff, particularly if you're going to be working in the Adelaide Hills. Super important that I'm not saying to give your client to make determinations on bushfire attack levels and say, look, bushfire attack level is this. But I think it's important to understand it enough to the extent that you can go, look, it looks like a bushfire attack level for this is going to be this, whereas in this area it's going to be this, to give your client a bit of an idea about things before it goes to the CFS referral. Because you're going to want to nut these things out as well as you can before that referral. Because when you have that referral, they're going to look at your track and say yes, yes or no, and then they're going to have a look at your bushfire attack level and go, you're 40, you're flame zone, you're 29, etc. Between BAL 12.5 and BAL 40, not massive constraints on what you can do building-wise. Yes, it all tightens up, but the big jump is between 40 and flame zone. If you're BAL 40, there's a lot more design freedom that can happen than if you're in BAL or in flame zone. Things really ramp up when you get into flame zone. If you're going to be working out initial things, and that's fairly clear to you as the drafter or the designer that this area is going to be a lower BAL, that one's going to be flame zone. Let your client know about that sort of stuff and start formulating ideas on that basis. So have a look at that, but that's what the CFS as the organisation will end up doing. They will provide a determination on bushfire attack level, and then what they say goes. Also, in regards to the determination of access, what they say goes. And then it's required for areas that are high bushfire attack level. Another external consultant you'll be needing is an energy rating assessor. Well, you might be able to go through the deemed to satisfy approach through the NCC, but like your private certifiers and so on, that's the mainstay of how you meet the National Construction Code requirements around energy efficiency. So they will determine the star rating of your house. So you have your house, and that will determine the star rating. There's been significant changes around this in the new National Construction Code 2019. I haven't really gotten into that because that's not really what we cover in this subject. We've got other subjects that deal with that far more intensely. Something it's for the pile of reading to do at some point in time soon. But I think what's happened in the 2019 is that there's been much more tightening up around some of the loopholes that existed where people could use reference buildings, etc. So rather than actually getting energy rating assessment on the building that they're building, they will say, well, we've built a building like that or basically the same, we'll just refer to that. So there are avenues for doing that. So rather than getting energy rating assessment on every single building built, particularly if we're building cookie cutter homes, that's going to be of interest to us. But that sort of thing does get abused as well. So people, at times people will have gone, okay, well, we know that this one's not going to pass energy rating assessment, so let's just refer to that building, even if there's next to no connection to it. So those things have tightened up, which is a fantastic thing. But beyond that, yeah, there's some changes in the new 2019 NCC, which I'm not completely over. But yeah, energy rating assessors, they'll determine that star rating. So it says in the NCC that you have to meet a 6-star energy rating assessment. They'll do that assessment on your building in accordance with there's a couple of programs you're allowed to use. They'll use those programs and they'll do that assessment, and they'll tell you, oh yeah, you're a 6-star, you're 6.5 star, etc. Where you sit in that. If you don't, they can provide recommendations to you to say, you've got to do this to your windows. You've got to have low E glazing or high SHGC glazing, or you've got to change your glazing, double glazing, etc. They'll tell you, do this with your windows to meet that 6-star. Or they'll say, add more insulation to meet your 6-star. So they can provide you with recommendations of what you need to do and what changes you need to make about your building fabric to meet that 6-star. But if you've got a decent appreciation for passive solar design, thinking about sun in winter, no sun in summer, and you build with a concrete slab, it's going to be pretty easy to meet those, that star rating. Various other different permutations around energy rating as well. In that, sometimes you see some absolutely shocking examples of buildings. You think that would be horrible to live in terms of the heating and cooling load on that. It's not only the use of reference buildings, but in terms of apartments and things like that, you get a general star rating for a development rather than for individual units, things like that as well. So plenty more. If you want to sink your teeth into it, understand that more. There's plenty more to know about that. Or your energy rating assessor may help you out with that information.
I see a lot of the new buildings, they've got no eaves.
Yeah.
They don't look like they're going to be very insulating and stuff. Do they just get other more points on other aspects? And is that how they get the 6-star rating?
Yeah, spot on. Yeah. So it might be that they're just bulk. Their insulation, they've beefed it up to R3 in the walls and R5, R6 or something in the ceiling. That they might have double glazing, they might have low E glazing. Low E glazing, I could not tell you if that window is low E glazing or not. You can't look at these things and go, that's low E glazing. And that's why it's also important that the stickers say on the glass when the house is new as well, that your site supervisor will want to check that the glass that's gone in is actually the glass that's required. So it can be things like that. So low emissivity glazing means it's glazing that allows the sunlight in, but then doesn't let much of that heat out. Or if you've got west-facing windows, you can have low SHGC, low solar heat gain coefficient, so that not much of that heat that hits the glass actually makes it into the building. Or you could, have high SHGC for north-facing windows, for example. But yeah, yes, it astounds me too. Sometimes some of the things that, although we've got these things enshrined within the NCC, some of the things that still get built as a result. That's the way that the industry is. Look, I think
I get it, because you need the flexibility for people to do different kinds of houses.
Definitely you do. Yes, definitely. People have different tastes and different considerations, and they might also be considering plantings that they'll be doing at a later date. I think, okay, we can have this place with no eaves and these windows that face east, but we're going to be, planting these large deciduous trees on this side, and this is what's going to happen. There's all sorts of things that can happen. There are different tastes and different budgets. And budgets are a massive motivator. It's why, and also confidence around a budget as well. I think it's a funny nexus that we deal with the larger project home builders. They've got an advantage in that it's like McDonald's. You know what you're going to get pretty much. You go to these. Well, actually, no. You've got an idea of what you're going to get, right? They say you can build this house for $99, but then that probably doesn't include doors or and then you walk out of there and it's going to cost you $180,000. That's a very typical sort of model that our base thing is this, but then if you want it to actually be nice to live in, it's going to cost you a lot more. Whereas going to building designers, they're sort of starting that on the back foot, because people think, okay, well, a building designer, they might cost me a lot of money, like through their about injecting their style and doing things that I don't want. It's going to be really, really expensive to me. And what's quite often not seen is that building designers, they have much more flexibility in those early stages to go, well, if you do this, and you save money over this, if you do this, you save money over that. But that's typically not seen, because people don't see the footings, people don't see all this stuff and it's not as easy for people to, you know, yeah. We're working in that sort of nexus, and yeah, whether you're builder designer, project home builder, or whatever, yeah, the, those relationships, that was also a massive driver of design, because project home builders, they want everything to be the same as much as possible, because they've worked it all out to being really efficient with materials. If they could do it as per their plans without any changes, then it's really efficient for them. So they're the drivers of design as well. Building inspector. So you only got to get a building inspector in if you're dealing with existing buildings, pretty much. So not always. So and yeah, and look, and sometimes you won't have a building inspector, but you want to get insight onto that building, and the best person to get that insight is a builder. If you've got a builder lined up for doing, let's say we're doing an addition, right? We're doing an addition onto an old bungalow. If we've got a builder lined up already, who we're pretty sure is going to do that work, we know them, we're wanting to get quotes and insight from them, then the builder's going to be climbing up in the roof and going, okay, we've got these particular rafters of this size doing this, we can do this or we can't do that. They're going to be making those choices, but sometimes we'll have a building inspector, and it's a very common thing when you're purchasing an existing property. When you put that contract in, you say subject to conditions. The two really common subject to's is subject to finance, subject to building inspection. Because we can't, even people who know a fair bit about buildings will still want to pay for a building inspector to come out, because they might find something they didn't notice, but also they're covered by their insurance. So, yeah. So typically, if you're dealing with an existing building, you may have a building inspector come out. So to determine any faults, whether they're structural or general conditions. So structural faults, you've got an old building in metropolitan Adelaide, very high chance it's going to have cracking. Like, very high chance. Is that cracking going to be bad? Like, is that a bad thing, or is that an acceptable thing? Sometimes it's really hard to work out. Cracks do all sorts of things. Structural engineers are fantastic at working out, is that crack a good crack or a bad crack? There are no real general rules of thumb to apply to that. So yeah, having a building inspector come and work out, is that bad crack or a good crack, or a crack that doesn't matter, is an important thing. But there's also going to be a whole host of other things that may not be easily seen. Another thing which is really common with old buildings is salt damp and moisture issues. And those, I've seen time and time again, moisture issues caused by people blocking up ventilation. So under your old houses that had strip footings and dwarf walls and suspended timber floors over that, they require ventilation underneath that to help get rid of moisture. Those vents are bricks with little holes in them on the outside of the building up above the ground. So often people have built additions onto a building, closed over, and poured a concrete slab and closed over those vents, and you get portions of the building which get inadequate ventilation, you get excess moisture in the soil there, and then that works its way up through the walls and starts eating away at the stonework and brickwork, whatever. So to have a building inspector spot those things and tell you, well, look, yes, we've got a problem with salt damp, that can be mitigated through these rectification works, etc. Provide fantastic information in regards to that. And also, they're going to be looking at roof lines, and are your hips doing this, and ridges and whatever, to get an idea of what's happening with all your framing. Get that to general condition. Yeah, all sorts of things could be going wrong with buildings. Other consultants that we may have, but I didn't produce separate slides for them because they're not as common, or you're not always going to have them out at these early stages. Plumber. So maybe if you've got interesting plumbing things to be done, yeah, okay, plumber. The electrician, you may have to have an electrician out at early stages to get get some information, but probably not, you know, spout cables. Where you will want to have an electrician out at a very early stage is when you're building in rural locations and you're making a decision on, are we going to run mains power there, or are we going to do a standalone off-grid system? Because running power can be incredibly expensive. One thing with electricity, the way it's supplied as alternating current, so 240 volts alternating current at your meter box there, or I'm talking approximate figures now, whatever. That AC, that diminishes in voltage over distance. So if we've got to run that AC cable for a couple hundred meters to cater for that, if we run a skinny cable for a really long distance, that we've got to have voltage drop happening there. To counter that voltage drop, we're going to have a really fat cable. So if you provide a fat cable, then you don't have the same degree of voltage drop. The problem is, fat cables is more expensive than a skinny cable, of course. You're paying for copper, and if you run a fat cable, that costs you more per linear meter, but if you've got 200 linear meters of that, that ends up becoming incredibly expensive. So you're going to want to have, in that situation, an electrician to say, these are the acceptable levels of voltage drop. So SA Power Networks say that we supply power at this particular voltage within these parameters. These are the allowable parameters of voltage drop that we can have. So you want that electrician to say, we need a cable this fat to run that distance. It's going to cost you $70,000 to do that. And you go, we're going to go with an autonomous power supply for building that area, or choose a different spot. So not always, but sometimes you want an electrician. A builder, as I mentioned before, if you're doing these rectification works or additions, that sort of thing, yes, you may want to get a builder involved very early in the process to get some insight. Acoustic engineer, Shepherd's Hill Road, yeah, probably not. Like, we're building a very simple house, but if we're building something on South Road, it might be a stipulation for council that you have an acoustic engineer look at things to say, we actually want this building to be usable. We don't want the people in that to be too bothered by all that road noise, or the airport noise, etc. So acoustic engineer may be required in some instances. Hydraulic engineer may be required in some instances. So we talked about contamination of groundwater. Well then, yes, a hydraulic engineer will be required in those instances, or where we've got groundwater close to the surface. In some instances, and quite often down in valleys and things like that, we've got groundwater that actually comes really close to the surface. You don't want to be thinking about, okay, we're going to do this cut and this fill. We're cutting 3 meters in, and then you hit some groundwater, and the whole thing is just going to be a soggy mess forever. You want to avoid these things. And I've built on a site once that hit a spring. Strange, I was doing a tank. It was out over on Kangaroo Island. They cut this tank pad. Turns out, there was a spring there, and so had to build on a firmer section. But these things happen. So hydraulic engineer sometimes. And then also possibly a lighting consultant. Now, okay, for a simple build at Shepherd's Hill Road, we've got to have batten fittings, for our lights. We're not going to have a lighting consultant for that. But for an office, we may have a lighting consultant. For a retail space, if we're building the Tiffany's building on North Terrace, we'll probably want to have a lighting consultant, to work out how we can achieve all that lighting. And the other one, thought of earlier but didn't add to the slides, was wastewater engineer. So that's it. Are there any other external consultants people think they may want to have in at some point in time? Yeah, no, I've got no more. No other people I'd probably call on for these projects either, but I just thought I'd put it out there. Any questions in regards to any of that?